Our final lesson in Chapter 8A is applications. We're going to just spend today looking at how to create a picture, and then we'll decide, based on given information, if we will apply law of sines or law of cosines to solve. Terminology that we're going to want to be familiar with. We'll start off with course of a ship or plane. It says the angle or bearing is measured clockwise from the north to the direction of the ship or the plane. We're always going to use 3 numbers to represent a course of bearing. If we start up at the top at 0, you'll rotate in a clockwise direction until you get to the part of the angle that represents where the location is for the plane or ship. So this may have a bearing of, maybe 135 degrees, something like that. To practice drawing these, I have some examples down below. It says sketch each bearing for a ship. Our first bearing is 050, and ultimately that just means 50 degrees. But we always have a placeholder of 0 if our measure is less than 100. What you'll do is you'll just kind of pick a pivot location or a pivot point, and we'll draw our due north symbol. I'm just going to write an N at the top for north. Now, a 50-degree location is going to start at 0 at the top and rotate just over halfway in quadrant 1. So that would be a 50-degree location. Our ship or plane would be somewhere along that orange ray. And that's the bearing. Let's try the next one. For 130 degrees, that's going to be a little bit greater than 50, obviously. Again, we just pick a point, and we're going to label our due north, kind of our start, little arrow at the top with an N. To rotate 130, that's going to be greater than 90. That means we're going to go greater than a right angle direction. So we're going to go this far. That's about 90 degrees. And if we go a little bit further down into quadrant 4, we'll label that as our 130-degree bearing for our ship in a clockwise direction. For our last example, 330 degrees is almost the entire way around that pivot point. If we make our due north location, we still have to count our measure in a clockwise direction. If we go a quarter of the way around, that'd be 90. Halfway around would be 180, 270. So 330 goes almost all the way back to the top. That goes all the way around to a 330 bearing for that ship. The next part of terminology that you'll want to be familiar with in surveying is called a compass bearing. This is measured a little differently than our course bearing for ships and planes. It says a compass bearing is given as an acute angle. So now your number doesn't have to have the 3 digits, but it'll be between 0 and 90. You're going to start from either the north or south line, and you're going to rotate towards the east or west. Now your measure can be clockwise or counterclockwise. So take a look over at the right. We have a measure of N20E, and what that means is we start at the north compass, and we rotate 20 degrees towards the east. We're going to rotate to the right approximately 20 degrees. Let's plot each location down below. Our first compass bearing, N50W. N means we're going to start with our due north location, and we're going to rotate 50 degrees towards the west. So the west is on that left-hand side. So take a location somewhere on that north line, and we'll rotate just beyond halfway towards the west to mark a 50-degree angle. So if 50 is at the top, then 90 would be at the bottom. 40 would be at the bottom because they should create that right angle. So just kind of some information that we would be able to use for maybe a different part of the problem. Let's try the next one. Here we're asked to sketch south 20 east. This time we're starting towards the south, so we're going to use this direction at the bottom. That's going to be the base from where we start. We're going to rotate towards the east, so to the right, a total of 20 degrees. So not very far, maybe like so. That would be our rotation to the right, 20 degrees. So then from there to connect to the east, that would be 70 more degrees. Again, something we could label later. The last comparison that we're going to want to do will relate to parallel lines and angles. Taking a look at the picture down below, it says comparing parallel lines and specific angles. Now in that first picture, it kind of looks like a distorted U shape. If you look at the two vertical segments, these two segments would be parallel to each other. Back in geometry, you labeled parallel lines with an arrow at the top and bottom. Angles 1 and 2 are in between those two parallel lines. They're called consecutive interior angles. And from geometry, they have a special connection. They're not equal to each other, but when they're in between parallel lines, they add up to 180 degrees. Something then that we could say is the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. As we draw pictures, maybe we'll have a due north for one part of the problem and a due north for the second part of the problem. That's how we could compare the angles in between. Let's take a look at the middle picture. For this example, we maybe have a due north up at the top and then a south. So they're kind of going in opposite directions. Now notice angles 1 and 2 aren't in between on the same side of that line that connects them. They're on the opposite sides. So angles 1 and 2 are on opposite sides. Those are known as alternate interior angles. And that's another rule from geometry. Alternate interior angles. Unlike consecutive interior angles, they're not going to add up to 180 necessarily, but they do equal each other. So in this kind of picture, angle 1 is going to be equal to the measure of angle 2. And that's something that we could work with as we're setting up a word problem. All right, one more to the right. We have just 1 and 2. Notice we may have a due north for that first part. And this almost looks like one of our compass or our course bearings for the ship and plane on the last page. Here, angles 1 and 2 have a specific comparison because they go around the same pivot point. If they go all the way around, the two angles will have a sum of 360. We would say the measure of angle 1 plus the measure of angle 2 is equal to 360 degrees. Now, all of these formulas in this section will help us create the pictures for the rest of the word problems below. For our word problems today, all we're going to do is create the picture. So we're really just going to use the given information kind of in the first part to set up a picture. The first question is very similar to just creating a plain kind of course bearing for a ship or a plane. It says ship A spots ship B on a bearing of 084 degrees. All we're going to do is create this picture. To do so, we're going to read from left to right. A spots B. I'm going to start at point A. So I'm going to create just a dot on my paper and call that A to represent ship A. I'm going to also draw in my due north location to start my course bearing. It says ship A spots ship B on a bearing of 084 degrees. Now that's almost a 90-degree angle. That means as I rotate clockwise, I'm going to go over here almost all the way to the right, maybe about that far. And I'm going to draw a ray or a point or a segment off to the right a little bit. And I'm going to label that 84 degrees. On the picture, we don't have to include the 0. So what this means is as the ship is kind of rotating their focus from A to B, they're going to spot ship B over in this direction. And that's all we're going to do with that picture for now. For our next picture, it says a ship proceeds on a course of 300 degrees for 2 hours at a speed of 15 knots, and a knot is defined as a nautical mile per hour. Then it changes course to 230 at the same speed for 3 more hours. How far to the nearest tenth is the ship from its starting point? So this kind of sounds familiar to that sailboat problem on the law of sines versus law of cosines worksheet, but our picture is going to look a little different. If we just want to create the picture today, we're starting off with a ship proceeds on a course of 300 degrees for 2 hours at a speed of 15 knots. I'm going to pick a location kind of somewhere in the middle just because I know where this rotation is going to go. So I'm going to pick this point. I'll label it S for where the ship starts. And I'm going to draw my due north. Now, if the ship is going to rotate on a course of 300 degrees, that means I have to go all the way around. There's 270 and maybe a little bit further up to this location right here. I'm going to stop at that point. There's my 300-degree rotation. It says then for 2 hours at 15 knots per hour. So 2 times 15 would be a total of 30 knots traveled. So now we're actually going to label this segment 30 for 30 knots, which is the same as nautical miles. Then it says the ship changes course to 230 degrees at the same speed for 3 more hours. So where the ship currently is, I'm going to draw another due north and now rotate 230 degrees. So from that due north, I'm going to go beyond the orange line. Halfway around is 180, so I have to go a little bit further to get to 240 over here. Actually, I want to make that segment a little bit longer since they travel an extra hour in that location. So bring that down like so. Okay. So this angle measure is, what do we say, 230? So I'm just going to arrow kind of over to that purple, 230 degrees. And then it says at the same speed, so 15 knots for 3 hours. So now if we do 3 times 15, that's a total of 45 knots traveled, or 45 nautical miles. Okay. Then it says how far to the nearest tenth is the ship from its starting point. So our goal is just going to be able to connect, where the ship currently is back with the shortest distance possible to where its starting point is. And then we'll work on, after a little practice, we'll work on how to solve that. All right, here's our last word problem that needs a picture. It says an airplane leaves the airport on a course of 120 degrees at 400 miles per hour for 1 hour, then changes course to 70 at 450 miles per hour for 2 more hours. Except not spelled correctly there, sorry about that. How far is the plane from its starting point? One thing to note, I think I did do a typo right there. That should say 070, not just 70. Sorry about that. All right, let's see if we can create a picture. Let's locate where the airport is. So now I'm just going to pick a point and label it A for airport. It says the airplane leaves the airport on a course of 120 degrees. I'm going to draw my due north and start my clockwise measure from there. 120 degrees is bigger than a right angle, and it'll go slightly down here into quadrant 4. And I'm going to draw a segment. The plane at that location, or at that time, it says traveled at 400 miles per hour for 1 hour. That means that distance is just going to be 400 miles traveled. It then changes course to 70. So 70 is a pretty abrupt course change. From where the plane currently is, we're going to draw another due north and then rotate 70 from there. I'm going to start just with my arc and create a 70-degree angle, which is almost a right angle, and I'm going to go in this direction. So now it says the plane travels at 450 miles, so it's going a little faster, for 2 hours. So I want to make that segment kind of model the distance the plane traveled compared to the first segment we drew. If it's 450 miles per hour for 2 hours, 450 times 2 would be 900 miles. That's equals right there. So that's going to be that length on the right-hand side. Now that we have that labeled, we're asked how far is the plane from its starting point. So if we connect our segment from where the plane currently is back to the airport, whoops, almost. Get that in there. We're just looking for that segment in this triangle. And our goal, once we get comfortable with drawing these pictures, will simply be to determine can we get enough information to apply law of sines or law of cosines. And finally, the nice thing about this last picture is it's already drawn for us. Yay! I'm going to read it though to you, and let's see how the picture is formed. It says the bearing from Pine Knob Fire Tower to the Colt Station Fire Tower is north 65 east. So we can see over here on the left-hand side, there's our north 65 east kind of location. And you can see that that's from Pine Knob up to Colt Station. From there it says a fire spotted by rangers in each tower has a bearing of north 80 from Pine Knob. That's where this number is coming from, over to the direction of the fire. And then it has a bearing of, sorry, I'm going to erase that quick just so that it's not in the way for our work later. Has a bearing of south 70 east, so that would be this direction from Colt Station. So that's where those numbers are coming from in this picture. Our goal will be, when we start working on solving, find the distance of the fire from each tower. And we'll be able to apply either law of sines or law of cosines. So that's it for the video lesson. If you're in class, show me that you've completed the notes and then just do the pictures for 8.3. If you're watching this outside of class because you weren't in class today, log into the assignment page and either print this out or write these out on notebook paper.